So today we will start electrochemistry. So in this particular chapter, basically you are going to study about the electrochemical reactions, then electrolytic reactions, and you are going to study the factors which affects that, and the vice versa. We can say that. Now, first of all, what is electrochemistry? Electrochemistry is that particular subject in chemistry or that particular chapter in chemistry which deals with the electrochemical reaction. That is, means it deals with the conversion of chemical energy to electrical energy and vice versa. We can say that, electrical to chemical, and the factors affecting the rate of these particular reactions and all these things we are going to study in this particular chapter. So basically what I said, we are going to study about the electrochemical reactions, that is the conversion of chemical energy to electrical energy or electrical to chemical. Now, conversion of chemical to electrical energy, like for example I'll give you, like in your house you have seen it, that is the inverter we are having. So what it does, when the current goes off, you are getting the current from it. The battery and inverter is being there. So the battery, what it does there, what is the work there, what it does, it converts chemical energy to electrical energy. Now remember that that is a spontaneous reaction, that particular reaction which is taking place, it's a spontaneous reaction. There is a what you can say, a decrease in the free energy of the reaction, that is delta G is negative. If you remember it, the last year you have studied in thermodynamics, the value of del G is negative because it is a spontaneous reaction. Yes, it is a spontaneous reaction. As long as the current goes, we can say that, for example, let us say a power cut is there for half an hour, you are getting a continuous supply of current from it. Isn't it? Chemical energy is converted into electrical energy. What is that chemical energy? The dilute sulfuric acid which is being stored there. Got it? For that time, for that reason, time to time you are adding distilled water to it. If you know that, all these things. So it converts chemical to electrical. It's a spontaneous reaction. There is a decrease in the free energy of the reaction. That is, del G value is negative. We can say that. That what it happens in an electrochemical reactions. Chemical to electrical. This is the principle. We can say that. Clear? Now, another one which I have studied also in the lower classes, that is your electrolytic reactions. Electrolytic reactions, what happens is that electrical energy is converted into chemical energy. Now the reverse you think of. When the current is there, got it? When the current is there, what happens to the inverter of the battery? It converts the what you can say, the electrical energy to chemical energy. That means the electrical energy is being stored there. The electrical energy is being stored there in the battery in the form of chemical energy being stored there. When the current goes off, this chemical energy is converted into electrical energy. So conversion of electrical to chemical, that is called electrolytic reactions or electrolysis, we can say that. It is not a spontaneous reaction. Not a spontaneous reaction, because as long as the current is passing through it, electrical is converted to chemical. As long as the current passes through it, you switch off the current, it will not be converted to electrical to chemical, we can say that. So this reaction is not a spontaneous reaction. It is a non-spontaneous reaction, we can say that. It is a non-spontaneous reaction. You know the value of delta G will be positive, we can say that. Got it? The basic idea that what we are going to study in this particular chapter, we are going to study basically our studies will be related to electrochemical reactions, we can say that. Got it? Now, based upon that, we are having another two types of reaction is also there. Got it? We are having, that is metallic conduction, and we are having, that is electrochemical conduction. Electrochemical conduction, we can say that. One is your metallic conduction, another is your electrochemical conduction. Now, what is the difference? You know that current passes through, what you can say, copper wire. Yes, in our house, it passes through the copper wire. Definitely the current is distributed with the help of the aluminium wire outside. So that particular conduction is called the metallic conduction. And electrochemical conduction, I tell you, when the electrical energy, chemical energy is converted into electrical energy, or electrolytic conduction also, where electrical energy is converted into chemical energy, we can say. Now, here the current is flowing by the help of free electrons which is being present in the wire. Listen carefully now. Here the current is flowing by the help of the free electrons which is being present, like copper. It's a good conductor of electricity because it contains large number of free electrons. Alright. But here, the electrochemical conduction, the current flows by the help of the free ions. Children, you may write it down, this one what I am saying. You make 2 columns and write it down. Listen and write. Here, the current flows with the help of the free ions. Alright, the ions which are being produced. For example, you know that is, let us say, sodium chloride. I am taking an electrolyte. It dissociates to give you Na plus Cl minus. So, the presence of this free ions helps in the conduction of electricity. Alright, so here the current flows with the help of free ions. Now, no chemical change takes place. When the current flows through the copper wire, is any chemical changes taking place? No. No chemical changes takes place. Got it? But here, yes, a decomposition reaction is taking place. Alright? A decomposition reaction is taking place. A reversible decomposition reaction takes place here. Fine. Next, here, in case of metallic conduction, so what you find is that the matter is not transferred from its position. Is the copper atom itself is going? Copper atom itself is going from its position? No. Matter is not transferred. Matter remains in its own position. Here the matter is transferred. Sodium ion and chloride ion, they are the ions. They are itself matter. Matter is getting transferred from its position. We can say that. Clear? So there is a transfer of matter from one end to the other end. We can say that. Now, next is, that is metallic conduction. What you find is that, as I said you, that it is taking place with the free help of free electrons, electrochemical by the free ions. Now here, that is chemical reaction does not, what you can say, does not take place. That is, what you find is that only the physical conditions changes, we can say. So here, what you can say, here the no chemical change is taking place. Here a chemical change is taking place, you can say. A decomposition reaction, we can say, take place. A reversible reaction is taking place. Alright, so here, that is, you find it out that these are the some of the differences between metallic conduction and electrochemical or electrolytic conductions, I should say that. Fine. Now after that, we are having, based upon this, we are having, that is, 2 types of electrolyte. Because you see, for electrolytic conductions or for electrochemical conduction, for electrochemistry, rather I should say in one word, we want 2 electrolytes. Got it? We are having 2 electrolytes. What is that? We are having strong electrolyte and we are having weak electrolyte. Strong electrolyte and weak electrolyte. Of course, non-electrolyte is there, but that is of no use to us. The strong electrolyte is what? Strong electrolytes are those electrolytes which dissociates almost completely into its ions. They are known as strong electrolyte. Which dissociates almost completely into its ions. Don't say dissociates completely. No, because efficiency is never 100%. Suppose if you are taking 100 molecules of strong electrolyte, it will not dissociate. All the 100 will not dissociate. Maximum to maximum 99 will dissociate. Alright, maximum to maximum 99, because some energy will be wasted in overcoming friction, in overcoming resistance and all those things. We can say that. So strong electrolytes, again I repeat, strong electrolytes are those electrolytes which dissociates almost completely into its ions. The degree of dissociation is maximum, we can say greater than 30%, the degree of dissociation. Alright, degree of dissociation I have studied in the first chapter, that is denoted with the letter alpha, degree of dissociation, isn't it? It's greater than 30% here. Degree of dissociation is greater than 30%, and here it will be definitely, it will be less than, much less than 30%, much less than 30%, we can say that. So now weak electrolytes are those electrolytes which does not dissociate almost completely into its ions, or rather I should say weak electrolytes are those electrolytes which dissociates feebly into its ions, feebly, partially it dissociates. Now for example, we can say that here if you take 100 molecules of a dilute H2SO4. Now dilute H2SO4 is a strong electrolyte. Alright, if you take 100 molecules of dilute H2SO4, then it will 99, let us say, will dissociate into its ions. But if you take here 100 molecules of ammonium hydroxide, then hardly 10 or 15 will dissociate, or maximum 20 will dissociate into its ions. We can say that. That is the difference between strong and weak electrolyte. We can say that. Now there are many strong electrolytes are there. Mineral acids, dilute HCl. Remember, dilute, not concentrated. Concentrated means it is a covalent substance. Dilute means when it dissolves in water, then it becomes, what you can say, ionic. Because water has got a high dielectric constant which helps to dissociate the electrolyte into its ions. That's it. So here dilute HCl, dilute H2SO4, dilute HNO3, all these are considered in case of mineral acids, they are considered to be a strong electrolyte. Similarly, sodium hydroxide aqueous, potassium hydroxide aqueous, got it, they are considered to be a strong electrolyte. Salts, basically all the salts of strong acids and strong bases like NaCl, KCl, KNO3, NNO3, but it's aqueous solution, remember that, salt solution I'm saying. Got it? Always it should be in solution state, because in solution state only dissociates into its ions. Like in lower classes you have studied that why solid sodium chloride does not conduct electricity. Solid sodium chloride, why it does not conduct electricity? It does not contain ions or what? Of course it contains ions, but the ions are not free in case of solid state. But in aqueous solution state the ions are free. You have seen the equation just now I wrote it. Alright, when you dissolve sodium chloride in water, just now I said you, water helps to dissociate into its ions. Which one? Sodium chloride into its ions. Why? Because water has got a high dielectric constant, due to which sodium chloride dissociate into its ions. So, salts of strong acids and strong bases, of strong acids weak bases, and weak acids strong bases also behaves as a strong electrolyte. But the weak electrolyte are ammonium hydroxide, like calcium hydroxide, got it? Magnesium hydroxide, we can say that. Clear, they are weak electrolytes. Similarly, weak acids like your organic acids like citric acid, acetic acid, vinegar. Got it? So carbonic acid, they are considered to be as weak electrolytes. Similarly, that is the salts are weak. Basically, all the salts are strong electrolyte. Some salts are there. Like suppose if you say what is that? Like salts are weak acid and weak base. Weak acid and weak base means like ammonium formate or ammonium acetate. They may behave as a weak electrolyte, we can say that. So this is about a strong weak electrolyte I said it. Thank you very much.